This will be the first video in a new format where I'm going to provide a devlog every couple of weeks about what's been going on with the project. I'm still likely going to dive down into the code, especially at this point where that's where everything is happening. But I think that that's going to be a lot more interesting than some pretty dry sessions where I'm just leading the agents through things. So I asked I asked Gemini to prepare a summary of the last couple of weeks, and I thought that that would be, and I'll probably do that each time. I thought I'd just kind of work through the things that have recently changed and kind of talk about the project and where it's going. And I'll just work through them in order. These are not in chronological order. I asked it just to lump all the similar work together, and it looks like it gave me five entries. A really big one was the shift to focusing on standing up infrastructure and packaging deployment. One of the really big goals for me in this project is to be able to have a really, really nice test harness so that I can spin up the infrastructure easy, test it with a large number of clients, tear it back down. And so I got started on that in the last few weeks here. So if I look, I ended up with probably a number of things, right? So I have a bunch of Docker stuff for building the images so I chose to go with native packages for deployment. So currently I'm building Debian dev files for Debian and RPM files for Amazon. And these do target the specific distro, right? The way I chose to do it was, in fact, let's just take a look at one. So this will probably get cleaned up in time, but let's look at the Amazon one. The way that I am actually doing this is to have shell commands that run. So this just creates an image that I run that mounts the work directory so that you can run make build, basically, so that you can run the make release. And I like this approach because it kind of keeps a fairly generic make release process, although you still do have to deal with the individual packaging types. So like, this project wants RPM, this one wants deb, this is the names of the packages over here, this is the names of the packages over there. But I do kind of like it. So right now, what we have is, for example, if I do a Docker images, you can see, of course, that I have the base or the base containers images that I'm building on top of. So I have a simple make command to pull those, so I don't have to remember all the things to type. So I can do a make pull Amazon when I'm preparing to build packages. It's going to go out. It's going to make sure that I've logged in, that I pulled the current, whatever the current AL 2023 images is at that point. I also have the Docker file that I was just showing, the thing that is where you run the build. We have the simple command for standing those up, and those, for example, would be, but in this case, Amazon, because that is the, we need a make in front of that. And so it's going to simply build that particular, that little Docker file that we use to then eventually, and realistically, the way that this works is you are going to run the package command next, right? So I would run make package Amazon, and that's going to go do the interesting. That's going to go out and then make the package for specifically targeted for Amazon. My comment on that was interesting is the fact that it regenerated the cert. I was rearranging files and I deleted the certs that I was using, so it's perfectly what I would expect. So you, of course, also all of the local build and run and test still works. So if I just do make, of course, I'm still just building everything locally. One of the things you'll notice here is I did a bunch of work on the versioning. So if I do, let's do a clear make version. This is the current version that we are releasing, and what we're looking at is a perfect full Semver version. So we have the Semver version number, a pre-release value, along with a metadata release. The metadata in this case is the current Git SHA head. So when we built the package, let's take a look at package out. So when we're building the packages, you're also seeing that we're doing that, but there's also a release value. This is the normal thing for all the different distributions, because you may need to change the packaging without actually changing which version that you're distributing. So you also have that release value. So all of that is there and follows the standards. So if I do make package Debian, we'll have a little bit of a contrast here. You'll be able to see it. So currently my only intention is to support, for the time being, is only to support Debian. That's what I build on locally, and to support AL2023, because that's what I'm deploying to. That works out well because right now I'm deploying to Amazon. I may choose to use like DigitalOcean in the future, and they tend to default to Debian for instance types. So it's a nice combination for me, and works pretty well. But when I get to actually building clients for people, it's really the same process I'm going to use, is to support the Linux distributions, which will be just to add various distribution targets to that package. Okay, so the thing I wanted to call out here is if we come back and look now, we have this one dev file in. You'll notice that the format of this is actually different. We have, in all cases, the package name is the same, but you can see that the first separator is different because we're following Debian formatting standards here. In both cases, in fact, let's also look at make version. You can see here that the Semver is to have a dash and then a plus before the metadata, but the dashes are not allowed in the package names, and so the standard is to substitute with the tilde, so that's what's happening. The pluses are allowed, so we get to keep them there, and then we have the release number, which is just for when packages change, and then architecture and the file extension. So nice, clean, complete packaging system and versioning. I think that's probably enough detail on just that. See what else we had in here. So the Semver deployment configuration. We had to add a little bit. I'm trying to keep most of the configuration as just compiled into the code because I'm not distributing it to anybody. It's simpler if I don't have to deal with external files. But right now, one thing that I chose to deal with the external files is the certs. So we are packaging so we're using pinned certs, pinned self-signed certs between the client and the server, and they are going to be installed as external files and then loaded. Okay, moving on. Sorry. Core server architecture and networking. Okay, that also was a big piece of work. One of the things, let's see if I can jump over, make clean all. Okay, how do I want to show this? So there is now Sorry, I am at a loss at the moment. Make help. What I'm looking for is it got renamed and I lost it. My brain. Okay. So, so make all. Okay, so we've seen it run it. And I think that was it. It's just I had done a make clean all and lost it. Let me get here. Okay, I had two problems. I've renamed this from the dependencies folder deps from vendor. So I was looking for the vendor folder, which had been recently renamed. And then the second thing was that I had done a clean all and it wasn't even here to begin with. But if we drop down in the deps folder, we only currently have embed TLS as a dependency, as an external dependency. So embed TLS as a package wasn't immediately available in AL 2023. And I knew that I likely am going to run into the similar problem when I go to build it for Windows in the client, when I go to Mac OS, when I go to whatever distribution. And so I also kind of just wanted to tackle the problem of having a true external dependency that was by source. And so this is how the solution looks. Let me back up one directory. Actually, let me clear and ls. So there is a deps directory, and in the deps directory, there's going to be a source folder. Right now, I probably want to, in the future, change how the make clean is working, but right now it is wiping. Well, no, the clean isn't wiping this. The clean all is wiping this. But we have a source folder. We're basically checking out the project from GitHub, and that is what the embed TLS directory is. Then any build artifacts that it makes well, okay, so that's too much. All of the necessary pieces for CD build. So we've only built the Debian since we've done this, CD Debian, and of course, what we're doing is we're just installing that library to this particular directory, and then we add these to the link path, and we add these to the header path, and so it's available to us while we're building. Now, if necessary in the future, I'll also have it also create the package config for something if I need to, if for whatever reason this isn't enough for us, if we need compile flags for something or whatever. So that is, how did I get down this path? Because I was talking about the integration of DTLS. Okay, so the other thing that we got going on with that, let's drop up to the top level of the project here. What I've done is we have created a DTLS wrapper. In this particular case, it currently only supports embed TLS, but I will add an implementation that it will be a compiler flag so that we can choose to use OpenSSL's implementation. And there are other implementations. There's the GNU one. There's one called Wolf SSL, which is, I think, primarily a commercial product, but I think it has an open source offering too. I forget, but the intention here is that the DTLS implementation is going to be behind a wrapper with compile flags. Let's see if we can figure this out real quick. vim source DTLS H. So it's not here. eSource DTLS.c. Okay, so we're currently vim inc. What I was gonna get to here is DTLS. There we go. So we're currently pinning ourselves on the embed v2.28.3 implementation. And the reason I chose that one is because that was what was shipping inside of Debian so the first thing I did was I just made the code work with it. And when I did that, I was just using the built-in package on Debian. It happened to be this particular version. The current version for DTLS or for embed TLS, GitHub, is going to be something 3. Something. So if we look at I want releases, which is here, tags. That's what I'm looking for. So, they're already, so 3.6.4 is where they're currently at. Now, another notable thing about the implementation that I have done here, and it wouldn't have been something I would have immediately thought of myself. It actually came out of one of the Gemini suggestions that I decided to go down this path. If we look in, let me go find in the docs, in the vendor libraries here, what we're doing is the way that these are being installed is, let's see if we can find it. So this shows it right here. So we're actually creating we're building our code so that it's looking for the libraries in userlib space captain as opposed to just userlib. And then what we're doing is we're wrapping the launcher for Space Captain with this, which basically then just uses it sets the LD path so that only for us we look in the Space Captain folder first. The primary reason that I chose to do this is because that will let me build, for example, Space Captain with embed TLS on version 4 and deploy it to old Debian and not have a conflict with a library called Space Captain. Nobody else would see it or try to use it. It wouldn't be right. Okay, so that's the reason for doing it. So and this is kind of the implementation, and then we talk about it. It talks about how this all works in this particular file. So this is also a pattern that you will see that I will use, which is to, when I'm doing something that's a little unique, I'm definitely going to have it create a bit of documentation and drop it in the docs folder. Okay, so let's jump back to the here. So DTLS, that was an awful lot about that. There's not much to say about the epoll loop. It's still basically the exact same. The reason it's showing up here is because when we added the DTLS implementation, it of course had to update all of the epoll loop. And we did go through and do a little bit of improvement on the message module. So if we go look at source and then jump over to the messages, it's still really primitive, but we have more message types that are defined, and we have a little bit more code defined for it here. That isn't particularly relevant, really. So let me go back. It wasn't a significant change at all. It's still just they don't really do anything. We're throwing messages back and forth, but nothing's really going on there. Okay, the build system and the project structure. I used to be using a unified build. I don't have the documentation here anymore, but unified C project build. the basic idea behind these, and see if it even Unity build. So if you go look in Wikipedia for Unity build, it explains it. But the basic idea is that you're simply including all of the C files into one compilation unit. And so it basically compiles one file. I actually really like it. The reason I moved away from it was, I forget now, but there was something I couldn't do with it. And it came in when, I know what it was. And I don't know that this is mentioned on here. Let's get back here. Make file enhancements, code quality and style, code formatting, documentation. Okay, so this must have been from before, further back than the 21 days. But another change that I made and that I do want to talk about is if we collapse this and we go look at the source and we look at generic queue, let's look at the header. So this is the multi-producer, multi-consumer queue that basically is going to sit between the ePOL loop and the client workers. And it was hard-coded to use, initially it was hard-coded to use the message format as the payload. The type of the message was the only thing it could queue. Well, I'm going to have more need for queue in the future, and I wanted to experiment with this. And it seemed like an interesting idea, but I wanted to do kind of generics in C. And the way I don't think that this is original by any means. It's just it was a little bit novel for me because I had never done it before. But simply the way it works is the actual implementation for the queue is all done with void pointers. So every function, if we go down here, is if we find anything, but it's actually, it is typed, but is it really? That's interesting. I guess it ended up there. It's basically a void pointer. And then what happens is you're wrapping this with specific SC message types that just get cast away in the optimization. So the actual implementation code, as it's written as the code is written, is simply take this and then actually just call the actual generic version. The idea being, and I haven't actually verified that this is true, but the idea being that that should get completely cast away because it's just a redundant function call. It's going to look and say, well, everything on the stack is exactly what I need to pass, and just optimize it away. So it's a way of getting generics in C. And like I said, obviously I didn't think of that. People have, I'm sure, been doing it forever, but it was novel to me. I think it occurred to me from investigating the Q class at some point. I think I had seen one where it was entirely implemented as a macro. So you pass the type to it to kind of instantiate the code for it. And then it just left me thinking, and I thought, well, I kind of like this a lot better, and I think it will optimize it away. And I'm sure other people are doing exactly this thing. I don't think that it's unique by any means. I thought it was kind of interesting. And so that's what I have implemented here. I hadn't noticed this, but because I was really paying attention to try and getting, the final bits of work was, as I was working with the agent to do this, was to make sure that there was nothing here but an inner function call that was being typecast. And I didn't notice while doing it that, let's go back here, that it was, it's not, it is all, it is all void pointers. What I just didn't catch is that both layers have a type def for the response codes, and they're identical. It's just that so you can use the values with casting them because the values are identical, but they are named different. There is a generic one. There is a message one. That's what we were just seeing a second ago. Anyway, that is the implementation of the Of the generics, more or less, let's jump back to, let's see if I can get smart enough to open these in new windows so that I can just pop back and forth. Let's close the tabs to the right. So that wasn't listed here, but that was the reason for, um, oh, let me see if I can try and explain it, if I can remember it. Um, that wasn't the reason. I was thinking for a second there, I was thinking that was the reason that I wanted that we did the refactoring of the project's build system. It isn't the reason that I did the refactoring of the project's build system. What I wanted was the ability to turn on, for example, just the Q files. I wanted to elevate just the Q files debug level while leaving everything else at the default. And to do that, the individual files all need to evaluate the defined macro value, the log level. If you have it all mushed together, like I was originally doing in one C file, where it's just including the other C files, it's a single compilation unit. And as soon as you define log level, it's defined and you can't change it again. I mean, you can undefine it, but that made for a really ugly solution where you basically had to undefine it and set it and try and I wasn't going to do that. So instead the build system changed at that level. So now it's just a normal make file that produces object files for everything. Still using the dash mmd and mp flags to make sure that header files cause recompilation when they change. Okay, this is going back a ways, but I've been picking away and I have a pretty good make fumped. So I tend, as you will notice here, I tend to lean on make really heavy for simple targets so that I can just splat them out with my fingers. And one of them is make fumped, and that does the reformats all the code, and I have to make it know not to. I hadn't seen that before. It's reformatting the code. It has an ignore to ignore the vendor file. Ceiling format. And if we look for vendor, oh, okay, so I thought it did, but I'll have to add it back in. It needs to know to ignore the dependencies and not try to reformat them. That was what was mentioned here, consistent naming. So I am using this set of naming across the project. So SC, so everything gets, especially before it was one flat file. And so I really did have to pay attention to make sure that I had a module prefix on all the function names, because I couldn't have, if I tried to make two different Q class or Q modules or Q implementations or whatever, they have to be prefixed differently. But I just like the real cleanliness of all externs are essentially they have a project prefix. That's what the SC is, and then the module, and then the function name. And I do talk about the per file log levels right here. Okay, so that was the reason for doing that. Did I cover? Yeah, I did some documentation reorganization, but that is most of that. Centralized documentation. So I moved all the docs into the docs folder. I did do a bunch of work thinking about the game mechanics. They are primarily in the research documents. You'll see some really fun things in the research documents, like let's go look at, did this end up it might have ended up still in this folder. Yeah. So the speeds, okay, so these are super, super vaguely defined in my head. They don't mean, that I say anything about this now does not mean that's how it ends up. But I don't want to use warping to go from A to B. I want it to be, more like a hyperspeed kind of thing. And so I was originally working on this. I did some work on, well, if I have a max speed of 1,000 in the game, and I want to be able to get across the solar system in exactly 10 minutes. But then after I had, and it's a logarithmic scale. So, again, this really maybe doesn't make sense at this point in the game, but I was working on it. And then I got curious and I asked it to compare my speeds to warp speeds. And interestingly, they almost perfectly kind of have this comparison to warp speeds. So my speed to get across not the galaxy I said earlier, the solar system, my speed to get across the solar system in 10 minutes is warp 9.99, warp 0.99. And I thought that was kind of interesting that it is actually a little bit slower than warp 99, but that was the closest equivalent. And I thought it was kind of interesting that the speed ranges mapped out that well. Now, one of the problems I'm going to have when I go back to the game, you can see these are, I'm going to have to define like ranges. Okay, so my thinking right now is that I define ranges where combat can happen. I define different weapon types and systems will only be effective at various different speeds. You can't, or something like that. But it allows you. I haven't thought this through, so I'm off the top of my head right now. But the idea being there could be whole tech trees that are designed to expand the range at which, the speeds at which certain weapon systems are combat effective, or targeting systems are combat effective, or et cetera, et cetera. You get the idea. And again, I haven't really, that's just a way out there thought. It's many months away before I ever have to care about that. Jumping back over here, we were down in the very last one. So I did a bunch of work around game mechanics. Most of that was around the speed scale. But I also did kind of threw some mud at the wall for ship. Right now, all ships are defined as the exact same thing. And that's where I'm initially going. Because my focus is entirely on stress testing. So my goal right now is the 0.1.0 release. My goal is to be able to. Oh, I didn't even show that. I should. It's so straightforward. So if I do make help, I want to go out and test this infrastructure, this server at scale on Amazon. And my intention is that in the future, I will be running, the biggest instances I can run, and trying to figure out what the scale is that they can support. So we'll be running a fleet of headless clients against the server to measure it. But make infra up is what I need to go. So I don't think I talked about this. Alls I have going on here is I have an infra folder, and in the infra folder I have the Terraform necessary to stand up or tear down all of the pieces. And then I have a deploy script that knows how to go and install the RPM on them. So, that's really all that's going on here. It's incredibly straightforward. It's just going to stand up the instances. And then I actually have two pieces, though. I have the permanent infra and I have the dynamic infra. And the split for me is the dynamic stuff is what costs money. So if it costs money, it's in the dynamic, and I'm going to tear it down. If it's something I don't want to constantly tear down, for example, the S3 bucket, or things that don't necessarily cost me money, IAM policy, I can put that over on the permanent side. And when I normally run this command, I'm only standing up and tearing down the dynamic part. The permanent part is actually been removed from the Terraform state, so it's been removed from the Terraform state and put in a separate backup file, and it can't be manipulated easily. When I want to bring it back tear it down for real, All I have to do is, rename that backup file and then do a Terraform import. It's all back in the game. It's all back in the Terraform again. And now I can just destroy the whole thing. But we just, you know, stood up these particular instances. And I have another command that I gave myself here was infra status. This is going to change. It's actually going to grab like the status from the systemd status opinion of each of these clients. And then I have we have make. Let's do a make help. Make deploy all. If I type it right. So this is gonna. I've done a make clean all at some point. So I need a make package. A make package Amazon. We need to have. That's actually something I should fix, or at least fix the ordering of. This particular version that it's going to build already exists as an RPM up on S3, but it didn't look. So the very first thing it should do is look at S3 and see if it even needs to bother to try and upload it. But right now it does try to just upload first, and so this little script is, of course, just you're watching what it's doing. It's just going to SSH in. It's going to do the it's going to do the RPM install of this particular file. And then, it gives us the status and a little bit of info on the way by. Now, we also have, not rake, make help. There is, and I guess I didn't, did I not? There is a, so if I do infra bin SSH server, I have a bunch of simple SSHs like that. So I don't have to remember, I don't have to look up any IPs because I don't have any DNS set up. I don't have anything going on right now for this. I don't have to do any lookup. That figures everything out for me and goes and connects. It's going to be even more important with the fleet of clients. The way I expect that the clients will be running is, I'll run as many per host as I can without maxing out, or so that I'm only maxing out, not exceeding the bandwidth available to that particular host. So the server, of course, probably, it's unclear to me if I can, if I stood up 2 extra large instances and ran, can I run enough clients over here to saturate the bandwidth, or do I eventually saturate something else and not the bandwidth before I saturate the bandwidth over here? So the idea was that I can scale the number of clients separate from the number of headless clients running, the number of client hosts separate from the number of client services that are running on each host. Now, the other thing I have going on is, let's do make infra status again. You can see that I'm calling out telemetry here, and there will be a number of I don't know exactly how I'm going to configure it, but right now, given what little research I put into it, I'm almost certain that we'll be running a Prometheus Grafana with Loki stack, probably Alert Manager, and then using, I don't even remember what it's called, the Grafana service for alerting. So it's kind of all in that same wheelhouse. It looks like it's going to be the easiest way to do it. And so when I go to test these things, and realistically, I don't need the alerting, and I haven't even really been thinking about that, but that's the long-term plan. Initially, I'll just do Loki, Grafana, and Prometheus. And the idea, of course, is the way that I'm going to be stress testing this is the headless clients will potentially maybe be scriptable, but the real point of the headless clients is I'm going to have them connect. They'll have a little bit of random delay. They'll connect. Then they'll slowly start to ramp up the amount of load that they're putting on the server. So I'll be able to pick up a window. So I'll run all of the stuff, and they'll all start connecting. And interesting, my UPS just cycled. What was I saying? So, over a period of 15 minutes, let's say, the individual clients will slowly just I don't know how. I think I'll just have them so they infinitely kind of scale until they're getting back pressure network-wise. And the idea being is that you want to watch all the clients scale, and you want to watch the server scale, load, pick up, and handle it. And at some point, the server is just going to fall over. And that's what I want to be able to watch in Grafana. So as I'm optimizing this thing for performance, we can actually easily, repeatably test and measure what's going on with the server. Okay. I think I've been talking an awful lot. I didn't talk. This one last thing. I'm still looking for the best ways to do things, but what I have going on right now is I have one agents file, which is serving as like the memory file like you would be used to if you use Claude. Agents is the name that Codex uses for it. Gemini wants Gemini.md, and Claude wants Claude.md. But what I'm doing right now is I am trying to do it the Codex way, where I just have agents MD, and then I have these other ones symlinked in there. I'm not noticing a problem with it, so I think it's the right solution. I have asked it to, it was probably Claude or Gemini, I don't remember, but I did ask and have pretty much stripped out the agent-specific information. There's probably still a little bit of outdated info in here right now. That is one of the things I'm working on, is getting things cleaned up, trying to find ways to make the agents always remember to update documentation. The problem with that is that they kind of have to go scan everything to see, is there anything related to what I just did? And I am having some success with that, and I'll probably share that in the future. I won't be strictly limiting myself to just, hey, these are the code things we did. I probably will talk about my discovery with the agents as I go. I almost certainly will. In fact, that is a big part of what this project is for me. It's both me learning this systems level development, as well as trying to push the idea of agentic coding to the limit. I have not written. It's actually probably safe to. It is safe to say that I have not written any functional code in this through an editor in this project yet. I have made some edits in Markdown files. And that is literally the only time I've opened an editor. Now, some of those edits might have been in a prompt file that I had another agent generate. But even that's very rare. I tend to always ask for anything that's like a functional or code change through the agents. Like 99.9999999% of the time, if I've done it, it's been like once. But I have made a few edits where I've like deleted files myself, or renamed a file, or those kinds of things. But they're not functional code changes. They're just quicker for me to do on my own. Now, one of the things I've also struggled with is using multiple agents in the same project. And I've learned that I have to be really, really careful about what I ask Gemini to do, because I have a hell of a time from stopping it from going and changing files. So I'll have Claude ripping through some big change, and then all of a sudden I realize that Gemini is changing files right under its feet. And so I tend to do my research over in the other agents. But if I do ask them to review a plan, let's say I ask Claude for a plan, and I do ask Gemini to review it. I very, very strongly assert in that ask that I do not want it to change files. Otherwise, it just takes off and starts doing it. Anyway, I think that really wraps it up. This is going to be the format going forward. Every couple of weeks, there will be another video like this where I will discuss whatever has changed in the project, whatever progress is made. I will, in the next one, I will make sure to have a little bit better long-term plan. But for the next couple of weeks, the only plan I have is to work on getting this performance testing going. So I want to be able to spin up all the pieces, including the telemetry, all the telemetry agents. And I also want to be able to, spin up a headless clients, which don't quite work yet. I have headless clients in tests, but they're not actually a standalone RPM that builds on its own yet. But that's the goal for the next couple of weeks, is to get to that point where I have that really robust benchmarking and just basic world state management that the headless clients can make changes on, so that I can measure traffic, so that I can see the traffic between the servers and clients and change the amount of load that they provide. And then, I'll have a whole host of artificial message types, literally ones that are just intended to go use some amount of CPU, so that I can, in the test, I can say, well, make this call. And in this call, I'll be able to set essentially how much CPU load is in it as a value, and do testing that way. Anyway, I talked way too much. This is the format in the future. So no more daily videos. Nobody was watching them anyway, I know, but hopefully these will be a lot more interesting. I will see everybody in the future videos.